Right, hi kids. So I'm not here today. So what I want you to do is just make sure that you have the notes in front of you. Also, take out your homework from last night and you can check the answers. I'm just going to show you the answers. Remember, you can always pause and play these videos to make sure that you can go and repeat and see them over and over again. Okay, so your homework from last night, here are the answers. All right, so again, pause. And then on the back side, and all you need to do is to go up to this point. Right, so I don't need anything below there. So again, go back through it. If you have any questions, we can go over that tomorrow when I get back to class. So there we go. We're not going to do that warm up. What we're going to do is we're just going to get started today. So today we're going to talk about the vertical angle theorem. We're not going to prove it. We're going to talk about it, and then we're going to apply the vertical angle theorem. And then we're going to apply special angle relationships, solve for unknowns, and find angle measures. So unknowns are variables. All right, so we're going to find variables and then use those variables to find angle measures. So here we go. Here are your notes for today. All right, so the big keyword that we're going to be talking about today are vertical angles. Vertical angles are opposite angles formed by two intersecting lines. All right, so anytime two lines cross, one line and a second line, they create vertical angles. So what are vertical angles? Well, vertical angles are angles that are across from each other. So this angle right here and this angle right here, they're across top and bottom. This angle right here and this angle right here, those are vertical angles because they're across from each other left and right. They're the angles that are formed by two intersecting lines or two intersecting segments that are always across from each other. The reason we learn about vertical angles is because they have a very special property. They have a very special relationship. And vertical angles are congruent. There's your symbol, congruent, which means they're equal. They're equal in measure. That's why we want to be able to identify congruent or vertical angles. So if we look at our diagram over here to the right, we have two lines intersecting and we have four angles. We have angle 1, 2, 3, and 4. So with the idea of vertical angles being opposite angles and congruent, what we can do is we could say, all right, angle 1, we're going to use our arc mark to show congruency. Angle 1 is congruent to what other angle? Well, it'd have to be angle 2. And likewise, that's only one set of vertical angles. We also have angle 3. Now notice I'm going to put a second arc here because angle 3 is not congruent to 1 and 2. Angle 3 is a different measure. 1 and 2 are congruent. Angle 3 is congruent to angle 4, which is across from it. So anytime you have two lines intersecting, you will have more than one set of congruent angles. You will always have two sets. So here we had angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. So that's what we're learning today. That's what we're working with today. So if we really think about it, all the different things that we've talked about with our different angles, we had linear pairs, which equal 180 degrees. That's a line, so like angle 1 and angle 2. All right, angle 1 and angle 2 would be linear pairs. We talked about yesterday complementary. Complementary equals 90 degrees. So again, right angles. But we also talked about complementary being like two angles, like angle 1 and an angle 2, that add together to equal 90. All right, we've had supplementary, which also equals 180. So a lot of you are like, whoa, whoa, whoa. Supplementary and linear pair, aren't they the same thing? Well, they are and they aren't. Remember, linear pair has to be adjacent. They have to share the side. All right, here I could have 60 degrees and then something just a little further apart, not adjacent, not touching each other, I could have 120. Again, adding together to equal 180 degrees. And now our newest vocab word is vertical angles, all right, which are congruent, meaning that anytime you have two lines that intersect, all right, angles that are opposite or across from each other, like this angle, ooh, thought that would be a different color, like this angle, call that angle 1, and the bottom angle, angle 2, have to be congruent. Likewise, the right, I'll call the left 4, right and left 3 and 4, those have to be congruent. So linear pair is adjacent, adds up to 180, forms a line. I think that's a huge part, forms the line there, linear line. Complementary adds to 90. Supplementary adds to 180, but does not have to be adjacent. Notice this is not adjacent, they're just random angles. And vertical angles, again, are angles that are across from each other, opposite when lines, segments intersect. So, back to our notes now. So we're not going to do that proof. When I come back, we'll do that. But what we're going to do here is we're actually going to use our vertical angle theorem, and we're going to find missing angles. So here we go. Just like yesterday, if the measure of angle 1 is 32 degrees, boom, there's angle 1. Find angle 2. All right? So what we're going to do is anytime you get your angle, we want to put that measure into our problem. So 32 degrees, and we want to find this guy right here. Well, if you look, 32 degrees, or angle 1 and angle 2, these are vertical from each other. They're across from each other. So we would say these two are congruent. So we'd say their name is vertical angles. All right, and that's just the angle symbol. This right here, when I do that, this is really angles, or A-N-G-L-E-S. I'm just not going to write angles. I'm just going to do that, which means vertical angles. And vertical angles are congruent. So angle 2 has got to be 32 degrees. All right? So number 2 says, all right, well, if the measure of angle 3 is 109 degrees, find the other angle measures. All right, so that means any other angle in our problem, we got to find it. So we got angle 3, this is 109 degrees. Ooh, 109. Awesome. Now, all right, I look at that. I have angle 1, 2, and 4 left to go. Well, since we just talked about vertical angles, think, if angle 3, they gave us angle 3 is 109 degrees, what's angle 3's vertical angle? And you should be saying to yourself, it's angle 4. It's across from each other. So 109 is going to be the measure of angle 4. All right, because they're congruent. This is congruent to this. So I'm going to put angle 4 is 109 degrees. Now, how do we find the other two? I feel like they didn't give us enough information. Well, this is where we kind of have to block out some information that we see. Now, what I like to do, all right, is I like to use like a credit card or just literally something that can just block out my student ID. All right, something that can block out. Come on. It's a lot easier when I'm in school. There we go. Really? Oh. There we go. It's freaking me out. Anyway, what I mean by that is, all right, I'm just going to leave this here. Let's say I wanted to find, I don't know, angle 2, because it's set up for me to find angle 2. I want to figure that out. So what I'm going to do is I'm going to say, all right, well, 2 and 1 are vertical, clearly. They're across from each other. They got to equal each other, but how do we find 2? Well, if I took this little credit card thing here, and I just kind of turned it and rotated it, I kind of eliminate some of my stuff, but it allows me to see where I go from here. If I eliminate or I just kind of like block out angles 1 and 3, I see this. I see this line, and I see these two angles that form that line. These two angles that form that line are what we call a linear pair. This equals 180 degrees. So 109 plus angle 2 should equal 180 degrees. So to find angle 2, we're going to go 180 minus 109, and we're going to get 71 degrees. Angle 2 must equal 71 degrees because that and 109 have to add up to your linear pair. Well, that's awesome because now when I move that card away, I'm like, oh, I got 2, which means I now have 1 because 1 and 2 are vertical, which means angle 1 is 71 degrees as well. So angle 1 and angle 2 are 71 degrees. So sometimes when you get to multiple angle problems like this, right, trying to block out using a piece of paper, using your hand to cancel out some angles, so you can really focus on some angles that are a little more adjacent to the angle we already know their measure of, will definitely help you out in the long run. All right, flip your paper over. All right, now this is what should be on the back side of your paper. So, ready? So now what we're going to do is we're going to take our knowledge of vertical angles and we're going to go a little bit further. We're going to say, all right, I could totally do this. All right, I know that vertical angles are congruent. I, in problem number 3, do not have a constant like I did in the last 2 problems. So how do we do this? Well, we say, all right, this angle and this angle, even though I don't know what they are, they both have a variable x, which will allow me to solve an equation to solve for the value of x, because that's what you're going to need. Anytime a variable is in your problem, you need to find that variable first in order to then substitute it back in so I know what each angle actually is. Is it 20 degrees, 78 degrees, 112, all right? You want to make sure you know what x is so you can put it back in your problem, and we'll do that shortly. But right now we say, all right, I want to find x because that's what it says over here, and I also want to find the measure of angle 1. So that's the second thing I want to find. But angle 1 isn't going to help me find the value of x. Looking at the 2 angles that have x and saying, all right, 5x plus 5 and 7x minus 11 are what type of angles? They're vertical. They're congruent. So I'm going to go 5x plus 5. Okay, cool. Excuse me. I'm sorry. Computer's acting up again. 5x plus 5 equals 7x minus 11. And now that is the equation that's going to help us find x. So now we say, all right, geometry's over. Now it's algebra time. How do I solve for this? Well, since I have multiple x's in a problem, I always move the smallest x. So I'm going to subtract 5x from both sides. And it's my version of combining like terms right now because I'm moving the 5x over to the 7x. So I have one singular x in this problem. So I bring down my 5. Bring down the equal sign. 7x minus 5x is 2x. Bring down my minus 11. And there we go. Now I have 1x in my problem. And now I'm going to say, all right, I'm going to solve this by undoing, adding, subtracting. That's always what we do. Undo, adding, subtracting to get our variable alone. 5x plus 11 is 16 equals, there we go, 2x. Divide by 2. And you're going to get x equals 8. And that's our answer. So x equaled 8. So 8 is our value of x. So now that 8's the value of x, what I do right away, before I even go find angle 1, is I'm going to put that 8 back into my problem. So I'm going to go 5 times 8 plus 5. And then I just do order of operations. 5 times 8 is 40. 40 plus 5 is 45 degrees. Now here's the cool part. Since 5x plus 5 and 7x minus 11 are congruent, I don't even have to substitute this back in. This is 45 degrees also. It will be the same answer. You're going to get the same thing. So what I do is I now try to like get rid of this. I don't even want to see any of that. All I want to see is the 45 degrees. So just like the last problem, all right, I need to figure out the value of 1. And these problems, these geometry problems, they love doing this, all right? They love saying, all right, you're trying to find one angle, but you got to use another angle to figure it out. So how do we do that? Well, take a little sheet of paper, credit card, something, and what we're going to do is we're going to cover up anything that doesn't pertain or help us out with 1. So I'm going to do this. I'm going to turn my credit card like this, and I just got rid of the bottom angle. Now, why would I want to do that? What's the purpose of doing this? Well, what I'm trying to get you to see is that, hey, I have a line here. This is a linear pair. Angle 1 and 45 degrees forms a linear pair. They form a line, and a linear pair adds up to 180 degrees. So what that means is we can solve for the value of angle 1 by going 180. We'll go 180, which is the total of these two, minus 45, and that's going to be 135 degrees. So angle 1 is 135 degrees. But you could have never found angle 1 if you didn't find the value of x. So that's using linear pairs. All right. Here we go. All right, let's do this. We're going to pause on number 4. Let's go to 5 and 6. Now, some of you might be like, all right, I can totally do this, Mr. Clavin. I can totally do this. What I'd like you to do is if you think you can do it, pause the video and you'll see my answer at the end. Just scroll to the end. If you're like, wow, I have no idea. This looks really, really crazy. It's all good, all right? I'm going to actually hide this one over here so you don't get as discouraged. All right, and we're going to say, all right, how do we do this? Well, this is a multi-variable problem, and they're not scary. They look scary. They shouldn't be scary, but there's a trick. What you want to look for is the same variable twice. That's our goal. That's what you want to do. Find the same variable twice. What variable? X, Y, Z, P, Q, R. Which one do you see twice? So if I look here, I see a Y. I don't see another Y. I see a Z. Don't see another Z. Uh-oh. I see an X and an X, which tells me that I am going to start with X. That's how I'm going to start. I'm going to start with these two angles right here. I'm going to start with 4x minus 11 and 9x minus 4. And our goal is to say, all right, what do you do to get these two values? What is these two angles relationship? So I'm going to take my credit card that I have from up here, all right, and I'm going to solve. I'm going to try to see it. Now, these don't look verticals because they're not across from each other. So what are they? Well, if I take a little sheet of paper and kind of blur this out, these are a linear pair. They form a line. You see that? So what we're going to do is we're going to say, all right, they're a linear pair. I'm going to say 4x minus 11 plus 9x minus 4 equals 180 degrees. 4x and 9x minus 11, those are linear. So we add them up to 180 degrees. So now what we do is we say, all right, just like the last problem, multiple x's, how do we combine like terms? Well, our x's are on the same side, so we don't have to move the smallest variable. We just start combining. 4x and 9x is 13x. And then 11x, or negative 11x, and negative 4 is negative 15 equals 180. We're then going to undo adding and subtracting. Add 15. So we get 13x equals 195. Then we'll divide by 13. And we're going to get x equals, is it 15? I think it's 15. Oh, let me check my calculator. I always ask you kids. All right, so it is 13. All right, so it's 15. Awesome. So, boom, there's our answer for x. So we solve for the value of x. Now, this is one of the biggest things, all right? Our problem said, find x, y, and z. Well, we found x. Well, here's the deal. Once you find x, you need to put it into your problem, and you really want to no longer see this 4x minus 11. Like, you really want to try to eliminate that completely. So what I'm going to do is I'm going to put this 15 in for x into both these problems. Now, these are both not congruent. They're not congruent. You're going to have to do this twice. So you're going to have to go 4 times 15 minus 11. Well, 4 times 15 is 60. 60 minus 11 is 49 degrees. So watch what I do. Get rid of all this. All I want to do is see 49 degrees. And then what you can do is you can either go 180 minus 49 and get 131 degrees, or go 9 times 15 minus 4. Just substitute it in. And that also gets you 131 degrees. Sorry, cancel that out. And that's all I want to see. I just want to see angle measures. I just want to see 49 and 31 degrees. So now, find x, check, done, found x. Now, what do we find after that? Well, my next rule is, all right, now that we have constants in here, which we have 131 and 49, now we just look, go in alphabetical order. So I want to find y. Well, y is a linear pair with 131, but we just learned today that y is a vertical angle with 49. I love vertical angles. Vertical angles are so easy because I don't have to do any math. Once I know what 49 is, its vertical angle is y, so that means y equals 49 degrees. Boom. Check. Just found my second variable. So I get rid of y, and I'm going to put 49 degrees in here. All right, anytime you find the variable, always put it back in your problem. And then lastly, x. Well, x is this, or sorry, z. Z is the same thing. It's a linear pair with 49 and the other 49, but z is vertical with 131. So z equals 131. Ding. And I got my third variable. All right? Great. So let's do this. If you understood and you got those answers correct, let's take a look at this last problem. And I want you, all right, I want you to try this without me. I want you to try it. So pause the video. When you're done or you're stuck or whatever, start the video back up and let's see what happens. All right. So hopefully you got it right. All right. If you did, that's great. I'll show you the answers in a second, or you can fast forward to see your answers. All right. If you didn't or you're stuck, well, let's see where we're stuck here. All right. So it says find x, y, and z. Very similar to the last problem. So the rule when doing multivariable problems is find the variable that appears twice. And that is x. X down here and x here. Now in the last problem, the x's formed a linear pair. These two x's are across from each other, which means they're vertical. And that means that they equal each other. They don't add up to 180, they just equal each other. So what we're going to do is we're going to say, all right, 16x minus 20 equals 13x plus 7. And that's how you start off your problem. That's how we're going to solve for the value of x, which will then help us find the variable z and y. So now that variables are on other sides of the equal sign, you see how they're not on the same side but on other sides, we're going to move the smaller variable. So we'll subtract 13 over 13x, which will combine our variables now to be 16x minus 13x is 3x. And we're just going to bring everything else down. Minus 20 equals, bring down this, plus 7. All right, and now that we have our one variable we've combined, now we move our addition and subtraction. So I'm going to move this 20 over, or minus 20 by adding it. And I'm going to get 3x, oops, I don't like that it slides. 3x equals, come on, there we go, equals 27. And then I'm going to divide by 3, and I get x equals 9. All right, x equals 9. Lovely. Now, just like the last problem, x equals 9. Check. You got it off the list. But just knowing that it's 9 doesn't help me. Using that 9 and putting it back into my problem, that is going to help me. So I'm going to go and I'll take 16 times 9 minus 20. I put that in my calculator, and I'm going to figure out what that angle is going to be. 16 times 9 minus 20 is 124 degrees. So this equals 124 degrees. So now I'm just going to get rid of all this. I don't need to see what the variable was and all this stuff. All I care about is 124 degrees. And again, because these top and bottom angles are vertical, you could plug that into 13x plus 7. I'm just going to put 124. They have to be congruent. All right? Now, I need to now find y and z. Well, which one do you find? Well, there's only one of each of them, so it really doesn't matter the order. I know some kids want an order. We'll go in alphabetical order. So I cover up the top. I want to find y. And I say, all right, 124 and y, what's their relationship? Well, if you said linear pair, you're right. This is a linear pair. It forms a line, and we have an adjacent side. That means that these two angles add up to 180 degrees. So what we'll do to solve for it is we say, all right, well, if one of our angles is 124, we're going to go 180 minus 124, and you're going to get angle y, which equals, so y equals, what is it, 56 degrees. And that's what it is, because 56 and 124 add up to 180. All right, now I get rid of that little credit card thing, and I say, whoa, y and z, they're vertical. So what I can do is I can say 56 and this angle over here are congruent. So z equals 56 also. And check and check. And that's how you do that. The big deal when you have multiple variables in a problem is you just find for the variable that occurs more than once. Most often they'll occur twice, and that's the one you start with. So here's the deal. Your homework tonight is with the sub. So please go up to the sub and get your homework. All right. And this is your worksheet right now. This is a worksheet that I'd like you to be working on. All right. So it's a front and back. All right. Make sure that you're working on it. All right. We got some good stuff in here. So please make sure that you're working through it. Okay. Make sure you're working through it. And here's the deal. 14, 15, and 16 are system problems. So we'll come back. I'll come back tomorrow and I'll explain how you do those. So you're really just going to do 1 through 13. Okay. Have a great day. Please be good to the sub.